So how did 1.2 or 1.1 go? So hopefully everybody was able to work through those different practice problems and was able to get some good answers. So 1.2, what we're doing is we're talking about some different kinds of sampling methods. So again, this is probably one of the most important parts of statistics, and because this is where a lot of flaws can actually go in, because if you start off with a poor sample that's not very representative, then whatever data or that you end up getting is really not going to represent the population. And so again, unless you're trying to spin something in a totally opposite direction, which is the only time you probably want to do that, like it wouldn't be really advised. So in this case, as you notice, there's a lot of blanks here. So I'm going to have you guys actually go through and fill out all the definitions. So at this point, there's a little PowerPoint slide that you can go to and kind of write down all the different definitions and things like that. And so what I want you to do is actually try to apply these definitions to the different practice problems. So I'm going to try not to do any of these. I'm going to leave these actually all for you guys to do. So again, share your answers and stuff like that and see how you do checking each different sampling method related to the different types of samples and stuff like that. If you do get stuck or anything like that, feel free to message me. You guys can work together on this, obviously. I know it's a little harder since no one's around, but if you can chat with each other or text message each other, if you know each other in class, bounce ideas off of each other, ask me questions. But again, I don't want to kind of do any of this. I want to see how you guys translate these definitions into the different sampling methods. So there's a bunch of different practice problems, and so again, these will be available for you to do in the collaboration space. So fill a couple of these out so that way we can hopefully have answers to all these and we can kind of check each other's works and stuff like that. So practice 4. So with that one, what you're going to do is do a random number generator. So if you don't have a TI calculator, that's actually okay. So you can actually do a random number generator by just going to Google in this case. And if you just type random number generator, Google actually has one on there. So in this case, if I wanted to generate a number between 1 and 10, if I just hit the generate button, it gives me 8. And if I keep hitting it, it'll give me different numbers. So in this case, 5, 6, 4. And you can also change, so like one of the problems you're going to have to do numbers 1 to 60. So again, if you change it to 1 to 60, and it may ask to do more numbers, so you just hit it as many times as you need to or whatever. So again, in that case, that'll help you with practice 4 in this case. But again, if you get stuck on any of it, just let me know. I can help you work through it. But that's a nice way to do a random number generator. So this talks a little bit about sample size. So sample size, because that's kind of one of the things when you're talking about measuring like the population, like FCC has over 6,000 students, how many students would we have to actually survey in order to get a good sample? So it turns out sometimes getting a bigger sample isn't always better, especially if your random sample isn't very good. So for example, this statement here is kind of powerful. For a national poll, as big as the United States is, as long as you survey 1,000 or 2,000 people and they're representative, it actually does a very, very good job of actually giving you a representation of the population. So it's not like we have to survey 100,000 people or 1,000,000 people, anything like that. 1,000 to 2,000 people is pretty small. And so when statistics and sampling is done well, you can actually get really, 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 really good results. So the next thing is a little nice tidbit for any history buffs out there. So if you want to read that little bit on your own, it's kind of a cool little thing where, again, a survey wasn't done very well, and because of it, they made a prediction that was totally wrong. So again, that's where sampling and surveys come in very handy. So the other thing that can come in when we're talking about a sample that can cause other big mistakes other than choosing a bad sample and stuff like that has to do with what type of sample it may be and stuff like that. So let's talk about some other considerations here for when a study can go wrong, for example. So So one main one would be what's called a self-selected sample. Or another way to think about that is like a voluntary response sample. And the reason these can be bad is because typically if you're if you're volunteering something, then that means you're probably really interested in it or something like that. So again, these can be not necessarily the best ways to look for samples. So another one would be what's called a non-response sample. And again, this is similar to voluntary response. And so again, what you end up in a situation with non-response is the people in the middle sometimes don't necessarily, if you're kind of, everything's okay, you may not actually participate in the survey. So what you end up getting is either, like strong positive, oops, can't spell, or strong negative opinions. And so, and of course, people were really, really happy. People are not, totally disappointed. That's not the way everybody feels. There's going to be a mix of everything. But in this case, that's what you end up with kind of a non-response. So again, that's not necessarily going to give you a great survey or anything like that. So another thing that we can get is self-interest bias. And so these would be, surveys that are done by companies that have a certain, so for example, like Hershey's Chocolate, for example, if they were doing some kind of a survey, well, they're going to want to make this survey so that everybody and their brother wants to buy chocolate. They want it to be spun as, as good as possible. So if they're the one conducting it, again, they may try to choose people in the sample that they know are going to be really positive about Hershey's candy bars and things like that. So again, they can make the data look strong in their direction, but they didn't really necessarily get a good sample to do that. So another possibility that we can have is what's called like social acceptability. And with social acceptability, these are usually surveys that kind of are hot button things. So it could be surveys about drugs, it could be surveys about pirated music or movies or things like that. So again, there are things that aren't necessarily acceptable by people. So again, you're going to have strong opinions one way or the other about these types of things. So not necessarily the best way to do a survey. So you could have one where you kind of lead the people. So you could have leading questions. For example, if you wanted to talk about Congress, you could word the question as, how badly do you think this Congress has done? So by wording it that way, you've already kind of made it negative. You've already assumed they've done something wrong, and that's kind of just encouraging people to jump on this negative bandwagon. So instead of trying to ask a question like that, you would just try to say, what do you think about the current Congress or something? So that way people could give positive or negative opinions about it. You don't want to sort of spoon feed them the answers that you want. And so finally, the last possibility could be causality errors. And so in this case, it's assuming that there's a relationship between two variables that means one causes the other. So in this case, let me write that down so you can see it. So assuming that a relationship between two variables means that one causes the other. So, for example, a situation like that could be if I eat chocolate, then I'll lose weight. So, just because you eat chocolate doesn't necessarily mean you lose weight. It probably won't mean you lose weight at all. But that could be one of the things that you try to do. You try to relate two things, that, well, those are sort of linked together. I guess it could be something. I'm trying to think of a good one off the top of my head. Like if I eat peanut butter before a test, I'll get a better grade. Is that necessarily true or not? It's hard to say. So trying to like link two things together and assume that doing the one is going to cause the other one to actually happen. So again, these are some strange, like we won't get into a lot of details when it comes to this part of it, but it is things to be aware of when you're like looking at surveys and trying to figure out, does this look like a good sample? Did they try to sway the sample? Did they do things to try to, spin it in their direction and stuff like that? So again, this is kind of it for 1.2. So go back to the beginning, look at that PowerPoint slide, write down all the different sampling techniques, and try all those practice problems, upload them to your picture, your solutions to the collaboration space, and I'll see you back for video 1.4.